Want to consider obviously biochemistry and biological systems, and recognize that most of the time these reactions occur in aqueous solutions. It's not complicated. So water is critical, and either you're soluble or insoluble in water. We know that a solution is made up of a solid, which is the solute, dissolved in a solvent, which obviously in this case is water. And generally the solutes are soluble in water because they are polar, because the important thing is like dissolves like. So polar solutes are soluble in polar water. We've already seen that in a number of other molecules. We'll draw in the water molecule, we'll put in our lone pairs of electrons, we remind ourselves that this bond is polar and this bond is polar because oxygen is more electronegative than hydrogen, and so this is a polar molecule, like so. So think about sodium chloride. We know it dissociates into sodium ions and chloride ions, both of which are polar ions that are charged species that are going to be soluble. We look at a carboxylic acid, like so. We know this bond is polar, we know this bond is polar, so this is going to be soluble in water. Obviously then if we go a little further down, we've got an alcohol, again polar bonds, polar molecule, oops, sorry, getting overzealous there, soluble in water. We look at our amino acids, we've got an acid group, we've got an amino group, again polar bond here to the nitrogen, to the oxygen, to the oxygen, to the oxygen. This is a polar molecule. It's going to be soluble in water. We look at a longer chain lipid, obviously issues of solubility arise. We can see that this end is polar because we have this polar carbon-oxygen bond, polar carbon-oxygen bond, polar oxygen-hydrogen bond. That's the polar part. But this whole part on the left-hand side is non-polar. And so as the chain length increases, polarity decreases. This is hydrophobic. This is lipophilic. Over here we have hydrophilic and lipophobic. So as the chain length increases, solubility of the molecule decreases. So we need to think about this when we look at our macromolecules of carbohydrates, DNA, RNA, lipids, and proteins / amino acids. What are their functionalities? Do they contain polar functional groups? If they do, they're going to be soluble in water. So, but as we see that the alkane hydrophobic chains increase, solubility in water decreases. So that's critical as we look at that.